So here we have a following problem where we're asked to calculate the weight of this 10-foot I-beam, and it tells us that the density of steel is 0.2833 pounds per cubic inch. So they want to know how much is this thing going to weigh. So they give us the front piece of it here. So we have this I-beam, and this is going to go out 10 feet. Okay. So what we're going to need to do is we're going to have to calculate the volume of this here. It is a three-dimensional shape. We do need to work in volume. And as soon as we find the volume of this entire thing here, then what we're going to do is we're going to multiply that by the weight of steel, so that we know exactly how much this is going to weigh. Because of course it's going to weigh differently depending on what kind of material it is. So we do need to take into consideration that it's steel and multiply by that weight here. So we first need to focus on calculating the volume of this. And I would say when it comes to calculating the volume of this, definitely break this up into figures that we're a little bit more familiar with. We do not have a formula for the area of of the volume of an I-beam. That formula just does not exist. But what we're going to do is that when I look at this, it has a lot of rectangular pieces together. I have this rectangular piece up here, this straight I part right here, this is also rectangular, and then the bottom, our base of it here, is another rectangular prism. So what I'm going to do is I'm going to pull the formula for a rectangular prism, and I'm going to find the volume of my top piece, I'm going to find the volume of the middle piece, I'm going to find the volume of the bottom piece, and I'm going to add all three of those up together, which will give me my total volume, and then we'll work on calculating the actual weight of it. So let's work on finding the volume of our top piece. So the formula for volume of a rectangular prism is length times width times height. So let's see, so for calculating our length here, so how long is this thing? So if I'm looking at this I-beam here, we do need to keep into consideration that rectangles, or most figures, do tend to be symmetrical. Whatever this bottom piece down here, it would mirror to this one up here. Alright, so let's go ahead and plug into this formula here. So length times width times height. So if I'm looking at the length of this thing, well, in the problem it tells me that this is 10 feet long. Well, it's 10 feet long, but all of my other dimensions are in inches. So what we need to do is we need to take that 10 feet and we need to convert it to inches. So if I have 10 feet, I'm going to put that 10 feet over 1, and what I'm going to do is I'm going to multiply it by its conversion. So I know that 1 foot is 12 inches long. So again, whenever you convert measurements here, you always need to make sure that the measurements you're needing to cancel are across from each other on your unit fractions here. That way feet will be able to cancel with feet. Otherwise, if we multiply this across, 10 times 12 is going to give me 120 inches. So this 10-foot long beam is 120 inches. So I'm going to say that my length is 120. My width, well, let's see, how long is this thing here? So it says down here that this is 8 inches. That would also correlate to this up here. So I'm going to say that my width is 8 inches. And my height, this little piece right over here, says that that is 2 inches long. So let's go ahead and calculate this here. So let's see, 8 times 2 is 16. And if we multiply 120 times 16, we get 1,920. Now, what I'm going to do is I'm actually going to double this part right here, because if this top piece is 1,920 cubic inches, then this bottom piece also has to be 1,920 inches. So you can do times 2, you can just double it like this. So 2 of these pieces here is going to give me 3,840 inches. So then all I really have to do next is I have to calculate my volume of this middle piece here. So I went ahead and I moved that total right over here to this side while we work on the middle piece. That middle piece is also a rectangular prism, so we're going to be working with the same formula. So let's see, our length, this is still 10 feet long, which was 120 inches. Our width, so this thing here is 4 inches wide, right over here it says 4 inches. And our height, how tall is this thing here? Well, right over here it gives me a measurement of 14 inches. So 10 feet long, which is 120 inches, 4 inches wide, and then 14 inches tall. And when I calculate all of that together, so 120 times 4 times 14 gives me a grand total of 6,720 cubic inches. If I go ahead and add the 3,840 that we already calculated there, that gives us a grand total of 10,560 cubic inches. Now, we're almost there. So this is the volume of this thing. Now what we're going to need to do is calculate the weight of it. So we need to take this from 10,560 cubic inches is how many, or how much does it weigh in pounds per cubic inches. All right, so do pay attention to your measurements here. We have cubic inches to go to cubic inches here, but we do need to calculate by our weight here as well. So we're going to go ahead and take our volume here and convert it into our weight here. So we had 10,560 cubic inches, and I'm going to go ahead and put that over 1. We are going to multiply this by our weight here. So this says that we have 0.2833 pounds per 1 cubic inch is what that tells us there. So what's going to happen here is cubic inch is going to cancel with cubic inch, and we just need to go ahead and multiply this together. And when we do so, we get 2,991.648 pounds. And it does tell us to round to the nearest pound. So if we round to the nearest pound, this will give us 2,992 pounds. Wow, almost 3,000 pounds there just for that one piece. Otherwise, that is it for this video.